Hello to everyone. My name is Ivan Lopez and I'm doing this presentation with my colleague Uriol Morros that he explains his part after me. We are gonna explain how to implement an emergency stage model with simevents in MATLAB. First of all, I have to say that we have a real inform of one hospital that they assigns a different color to each patient according to their severity. Well, here we have the model in sim events. The first part is the green one. Here we generate the doctors and the nurses. In the second part, we have the triage sections with blue color, is where the nurses assign that color to each patient. And the last one is the doctor's visit and the patient's departures. Now we are going to explain that three different parts more concretely. Here we have the first part, the doctors and the nurses generation. Here we create the time signal. The next block here we generate the different shifts of each doctor and nurses. The next block is a block to pass from time-based to an event signal. We need to do that to work with event blocks. And the next one is where we create the resources that we have. And the resources are the doctors and the nurses. That's the second part of the model, the triage section. And here we have the assignment of the quantity of patients in each shift. Then, like the part before, we have to pass from time-based to an event signal. Then we have the resource acquire, where the model called to the nurses, and then that nurses in that part randomly we assign a different color to each patient in that part, the set attribute block. Okay, let's go to the third part. Here we have the last part of the model, that is the doctor's visit and patient departures. The first block is an output switch where they send the different patients to each doctor depending on the color attribute. Then we have the resource acquire block where we call the different doctors if they have a patient, and then we have to pass from time-based to an event signal like in the other parts. And then we have the visits with the server block. And then representing the departure, we have the releasing blocks in that part of here. And finally, here we have the results of the model. With that block of here, we can see the percentage use of every resource in every moment. And here in that part, we can see here on that block the absolute number of patients with each color. And here below, we can see the ratio of patients compared to the total patients. Now my colleague Uriol is continuing the presentation with his part. Thank you to everyone to listen and to be patient with me.
Hello everyone, my name is Uriol Morros Urdella, and today I'm going to explain the improvement I, alongside my colleague Ivan Lopez Pizarro, decided to implement for the emergency stage model. As my colleague already said, in order to see the work rates of the different kinds of doctors, we need to look at the plot from the resource use percentage. As we can clearly see, doctors in green and orange work from 70 to 75% of their shift, whilst blue and yellow only work about 20 to 30% of their hours, with red ones being more on the middle. So even if we took the ethical questions of fairness out of the equation, we can still clearly see that it's not an efficient way to run the place. And furthermore, we were asked to have no doctors work more than 70% of their shift. So we will have to implement some kind of solution. As my partner already explained, there is a point in the model where the simulation distributes the patients amongst the doctors. And that is where we decided to implement the changes. The first solution we decided to implement was to merge blue and green patients in the same virtual room, so to speak, and then redistribute them among green and blue doctors using a round-robin function, even though an equiprobable function would have worked just fine too. And this way we can share the resources much more equally and have it way more balanced. We can clearly see that the blue and green plots are much more similar now, and both are much more acceptable around the middle, especially green. The blue plot has a spike at the end due to the relative lack of doctors in the final days of the week, but it's still much better than it was before. We can clearly see that there is still room for improvement though, and that's why we decided to do the next change. We implemented the same thing we did before, merging the orange and yellow patients and then redistributing them with again the round-robin function, and this way we have we have the resources shared between yellow and orange. We had another idea for the solving of the whole problem, which was merging all four of them, orange, yellow, green and blue, and then redistributing them equally. But even though it would work just about as well, it would still have its problems. We thought that it would make things messier, and also that it would be messier in the real world. It would be harder to implement, and so we left it the way you can see it here. As we can clearly see, finally, this time the plot looks much more balanced than the plot we had at the beginning, and aside from the initial peaks, which are irrelevant, they are just a problem of the simulation. The equation is the plots are much better. None of them reach even reach over 70% of their work shift, aside from the initial peak, which we already said doesn't count. And this solution is much more efficient and better for everyone. Save maybe the yellow and blue patients, but it will make the emergency room work much better. So thank you for your attention. That has been my presentation, and I hope you enjoyed it.